All right, what's good, y'all? Link here, and let's go for another daily legal question. Question 2099. Find subsequence of length k with the largest sum. It's an easy one with almost 57% acceptance rate. So let's see how this one goes. Daily 2099. I haven't done this one yet, so let's see. So we have a list of numbers and then an integer k. Let's see. You're given an integer array nums and an integer k. You want to find a subsequence of nums of length k that has the largest sum. Return any subsequence as an integer array of length k. Okay. Okay. So it's not a continuous, so we can in this case we grab 2, 3. Have negative numbers. That I don't think that's gonna change a lot. So this is length 2. Okay. Can derive from this. Okay. Yeah. Let's see. So the first thing, first approach that comes to my mind is okay. So what's the? I mean, this is already an answer, right? Not the best answer, but it is answer. So when we get to 3, we actually want to delete. We want to substitute with the smallest number we have in this part of the list, right? In this case, we will go from 3 to 5. So we delete 1, we have 2 and 3. But now when we get to 3, we want to do the same thing. So boom, delete the 2, and now we have 2, 3, 3, 3. So if we always want the smallest number in the list, we can use a try, right? Min heap, store all the elements, store the first k elements, and then for each element that we're gonna go after that, we're gonna check if that element is greater than the top element of the heap, which is the root, which is the smallest number. I think that's all. Might be missing some case here, but let's give it a try with the solution. So let's import. So from I think it's heap q, import heap phi, heap pop, and heap push. Pretty sure we're gonna use all of them. Let's do heap is equal to heap phi. Let's do this. It will be this, but I think we can just do nums index 0 all the way to k. But we're not going to include k, right? In this case. So if we have two numbers, we're gonna go from 0 to 1, 0, 1, and that's it. But we're not going to include k. Okay. So for I in range of, so we start with k now. Do length of nums for I in range of k to k. If nums index I is greater than heap index, so is it the first one? I think it's an x 0. I'm not sure though. It can be the top of can be the last element. I think it's the first one. If nums index I is greater than heap index 0, we're gonna do heap pop from heap. That's how you pop. I always forget how to wait. Why this keep doing? Heap phi nums to the two nums index I from here. Oops, I made something here too. If heap, wait, what? Let's do well, heap's fine. Let's do heap. Is it because of the name? I can use the name heap. Nope, it's not it. heap uh, and heap index 0 where it's smaller than nums index I. We're gonna pop heap pop from the heap, and then I think the length. Oh, it has to be with this one. Oh, I think that's fine. Yeah. So if heap pop, we're gonna pop the smallest element from the heap, and yeah, yeah, we've got pop from the top of the heap, and we're gonna do heap push to this heap, and then we're gonna do yeah nums index up. And yeah, I think we can just return a list of the heap, right? Maybe not. I think return heap. Can you do an array? Okay, maybe we have to put every single thing. As heap file returns to in place. Yeah, I would do like I can just return a list heap. Apparently I can't. So let's do res equal to this while heap res dot append heap dot heap pop heap and res. Let's see. Oops, I probably just need the from here. Okay, let's see how this one works. Oh no, am I using the heap? Let's see. Right here, heap. Let's see. I think I'm using the heap the wrong way, maybe. Let's see. Oh, it's not. Yeah, I'm using. Is it heap pie? Is it heap pie? Let's see. I have a heap somewhere. Two. Oh, that's fine. The heap is none. It shouldn't be the case, right? Let's see. I just want to test here real quick. Oh, does it? Oh, that returns down. Okay, 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 yeah. No, that's fine. It's fine. Yeah. So it's just rest. Yeah, yeah, yeah. Is equal to this. It's been a while since I've used heap. So rest equal to this. We can name heap by rest. I can turn this into a heap. Actually, heap to make it easier. Heap by heap. You have all that, and then I think we can just return the heap, right? Now that we have this, yeah. Okay, this should be fine. Okay, looks good. Give us submit. I forgot how to use the heap, but okay. Wait, oh, is it because I got? Huh. You want those in order that they appear? Oh, it has to be. Yeah, yeah, it has to be. Okay. So I can't use heap because the heap changes the order of the things, right? Hmm. I can't use the heap then. Okay, so that's fine. No, that's fine. Let's see. I mean, at the end, it's just gonna be. I can't use the heaps because the heap's gonna change the order that I put the elements in. Okay, so that I won't be able to use heap in this case. Okay, so let's try another thing. I mean, you just grab this. Oh, it can't sort either because that's gonna change the order as well. I mean, can we do? Let's see. Mm, the largest sum. Let's see. How can we do this? We will start over here, and then we want three, but we need to get rid of one of those. So we get rid of one. Hmm. We get rid of the one, and then now we have this. But when we get to here, we want to get rid of the two, and in case it could be the whole thing, right? Yes. Okay. Um, Probably don't want to do in square in this case. Hmm. Thinking if we can do. I don't know now. Let's see. I think I'm overcomplicating this one. So 2, 1, and then when we get to 3, we want to remove 1. Oh, but what if it's yeah, we gotta keep the order. And then we can't have duplicates. Hmm. Oh, I don't know. Let's see. Oh, I know. No, I don't. Because I was thinking about tracking the index of the smallest element, but then that won't work. When we add this one, like how do we know? Okay, we're gonna substitute within this. How do we know this is not the smallest one we have? Okay, that's not gonna work. Huh. Actually, don't have an idea how to do this easy one. Let's try to think for a second. Try whiteboard, right? Yeah, I think it's the first time I'm actually whiteboarding an easy one. I don't remember. Let's see. Uh, uh, so we start over here because this is this should be an answer, right? And then when we get to 3, okay, so we're gonna remove the smallest one. In this case is 1. So we remove 1, and then now we add 3. But now when we get to 3, we want to remove 2, so we can add those 3. Maybe I can use the heap to help me. Maybe I can use the heap because we're gonna track these. Oh, we can track the index as well. We can track the index. And then once we get the index, we can kind of like, yeah, yeah, yeah. Okay, so I think we can use a heap, but we have like a tuple, the number and the index. Once we're done with this, we're gonna sort by the index, and then we print. I think that works actually. Let's see. What was my answer here? Let me grab this thing. Was this is it my answer? Let's see. Oops. Okay, so instead of doing this, let's do okay, so actually, let's do the following here. So heap is equal to this, y in range of k, but not including k. A heap, oops, heap, append a tuple. This tuple gonna have a nums index k, but this one's gonna be, we can have less than k elements, right? Yep, yep. So that's going to be the minimum between k and one of nums. Um, and then append this. So we're going to append the number and the index. So for I range of k to length of nums from 0 to k, the minimum between k and length of nums, heap that append nums index I and the index as well. We're going to heapify this thing. And then for I above, if heap and heap index 0, 0 is less than this, heap pop, hit push, but we don't want to push just this. We want to push this with the index. Okay, yep. You want to push the index as well. And then once this is done, we're gonna res is equal to this. We're gonna heapify. I'm just gonna do this a dumb way, but res equal to this. And then well, heap res heap heap current elements is equal to heap pop heap current is equal to heap pop heap. Let's see, heap push. Now we want to do the opposite, right? So current index. Oops, let me get to this. Current index 1. Current index 0. Oops, I need to specify the heap that I want to push. Forgot about that part. There you go. Now we have everything ordered by the index. Let's actually change this name to heap index. And then we do heap index by heap up from the heap. And then we're going to do heap index. Now we have res equal to this. This is super ugly code, but let's see. While heap index, rest append heap pop from heap index. But we're gonna do index one, which is the actual element. At the end, we're going to do the rest. This is, as I said, this is super ugly. There must be an easier way of doing this, but okay, give us submit. I mean, if the metrics are good, okay. Uh, not a good memory user at all because I'm how many heaps I'm creating right here. There must be an easier way of doing it, but then we're gonna. Hmm. Yeah, I'm using a lot. I wonder what this guy did. Okay, wait, he is sorted up to K. Oh, wait. Huh. None. If none in top K. And then what was the metric for this one? Oh, I can't see the time for this one. Interesting. I mean, this is linear, right? But actually, is it linear? It's not because for I range of n, if heap pop, heap push, this is log n, so n log n this thing. This is n log n. But I mean, the time was pretty good. Well, is that a better way of doing this? I don't know. Of course, I could. Yeah, I don't know. I mean, this works, so I'm wondering if there's a way to do this one without creating three heaps. Oh, this is not a heap, right? But two heaps, but we have three arrays, so three n space. But I mean, the time was pretty good, so I'm happy with that. Yeah, I think that's good for this one. I think that's all I have. Appreciate you guys for watching, and I see y'all next time.